Imagine building the most advanced, powerful digital brain in human history, right?
Mhm.
But you actually have to turn it off because the physical building it sits in is literally melting.
Yeah.
I mean, that is exactly the reality we are looking at in today's deep dive. Welcome in, by the way.
It really is the ultimate modern paradox. We've got this accelerating capacity to process information and just build these infinite digital worlds, but we are still, entirely tethered to a physical world that is currently breaking its own historical limits.
Okay, let's unpack this, because today we're looking at a very specific, highly detailed snapshot in time.
Right.
We're examining a publication of the Daily Tech Reader, and this is from Friday, August 7, 2026. So if you're an enterprise knowledge worker opening up this feed, you're probably looking for, software updates or market trends.
Sort of the usual morning check.
Exactly. But the very first thing you see, just dominating the top of the page, is a map of the United States. And it is practically glowing red with environmental hazard warnings.
Yeah, it's a stark contrast to what you expect in a tech newsletter.
It really is. And I want to start by looking at the eastern half of the country, because the primary threat here isn't just the temperature on the thermometer.
No, not at all.
The data shows this overwhelming blanket of moisture. For instance, New York City is facing a 98-degree heat index, but right across the river in Newark and Jersey City, the dew points are sitting in the mid-70s.
Which is brutal.
Right. And, I know high dew points are bad, but I'm struggling to see why a mid-70s dew point turns a normal hot day into a critical health hazard.
Well, it comes down to the biological mechanics of how the human body cools itself, right? We rely on the evaporation of sweat to pull heat away from our skin.
Okay, makes sense.
But a dew point in the mid-70s means the atmosphere is already saturated with water vapor. It's basically reached its carrying capacity. So your body pushes sweat to the surface of your skin, but the air just can't absorb it.
So the sweat just sits there.
Exactly. It just sits there. The evaporation process completely halts. And because that cooling mechanism fails, your internal core temperature continues to rise, even if the ambient air temperature isn't actually breaking 100 degrees.
Oh, wow. So you're basically generating heat with absolutely no exhaust valve.
Yeah, that's exactly it.
And looking at the data, this isn't just a daytime problem either. I'm looking at these overnight lows in Boston, and they're staying in the lower 70s.
Yeah.
On paper, 72 degrees doesn't sound terrifying, but the report flags it as a major vulnerability.
Yeah, the danger of elevated overnight lows ties right back to that atmospheric saturation we were just talking about. What we're seeing here is a fully saturated boundary layer.
And that's the lowest part of the atmosphere.
Right, the lowest part where we live, where all our infrastructure is built. Water vapor is actually an incredibly effective greenhouse gas on a localized level. So during the day, the ground absorbs solar radiation. Normally at night, the ground releases that heat back out into space.
Like radiative cooling, right?
Exactly, radiative cooling. But when the boundary layer is packed with moisture, it acts like a thermal blanket. It just traps that outgoing radiation and reflects it straight back down.
It's like trying to dry yourself off after a shower with a warm, soaking wet towel. You aren't actually removing any water or heat. You're just, moving the moisture around.
That is a perfect mechanical comparison. The environment simply cannot hold any more water or absorb any more heat. And the consequence of that trapped heat is that human infrastructure never gets a chance to recover.
Oh, because everything stays hot.
Right. Transformers on the power grid don't cool down, which leads to thermal degradation.
Yeah.
And your air conditioning units are running 24/7, which just pushes the grid to its absolute limit.
Man. And because the air is essentially this giant saturated sponge, we are seeing some terrifying localized threats in this data.
Yeah.
Like northern New Jersey, specifically towns like Morristown, Somerville, and Flemington. They're highlighted as highly vulnerable to flash floods. The ground is completely waterlogged from storms earlier in the week. But the report specifically notes that the tropical Atlantic is entirely quiet.
Yeah, completely quiet.
So there are no hurricanes out there. I'm trying to understand the mechanism here. If there's no organized tropical storm pumping water into the coast, how is a place like Flemington facing catastrophic flood threats?
Well, what's fascinating here is you don't need a named hurricane to trigger localized catastrophic flooding when the atmospheric sponge is this full. The report mentions a weak shortwave pattern draped over the mid-Atlantic and the
On
Carolinas.
shortwave.
Yeah, it's essentially a small ripple in the upper-level wind currents, like the jet stream. Usually these winds act as a steering mechanism to push storms across the continent.
Okay, keeping things moving.
Exactly. A weak shortwave means those steering currents are virtually non-existent. So when a standard afternoon thunderstorm develops, which it easily does given the heat and humidity,
It just doesn't go anywhere.
it doesn't move. It taps into that saturated boundary layer, pulls up an unusually deep pool of water vapor, and just wrings itself out over one single location for hours.
The storm just anchors itself in place.
Yes.
So if it forms over Somerville, it just dumps water continuously on ground that has zero capacity to absorb it. And I guess the water has nowhere to go but up into the streets.
Which is exactly why the flash flood risk is so extreme.
Unbelievable.
Yeah.
And this stationary fire hose of humidity, it stretches all the way down the coast. Like Miami has hit a 57-day streak of highs at or above 90 degrees. New Orleans and Baton Rouge are climbing into the mid-90s with heat indices of 106.
The Gulf Coast is essentially trapped in a feedback loop. You see notes in the data about sea breeze collisions in Tampa, or scattered inland storms in West Palm Beach.
Right, providing like a brief burst of rain.
Yeah, but they don't change the underlying air mass. They just deposit more water onto hot concrete, which then immediately evaporates back into the boundary layer, and that just further increases the humidity.
So it just makes it worse.
Basically, the entire eastern seaboard on this day is functioning as an unbroken steam engine.
So we have an eastern atmosphere that is literally trapping heat and drowning in moisture, which makes the transition to the western half of the United States on this map so jarring.
Oh, completely.
Because we were looking at the exact opposite mechanical extreme. The localized, heavy humidity of the east is replaced by these massive, sprawling, interconnected systems of dry heat and fire in the west. The report notes a highly amplified heat dome dominating everything from Texas to the Pacific Northwest.
Right, and the heat dome is the counterweight to the East Coast's moisture. It's a massive ridge of high pressure in the upper atmosphere. In a high-pressure system, the air physically sinks toward the surface.
Subsidence, right?
Yes, a process known as subsidence. As the air sinks, the atmospheric pressure increases, which compresses the air. And basic thermodynamics tells us that when you compress a gas, it heats up.
Makes sense.
This sinking motion also suppresses cloud formation, so the ground is exposed to maximum uninterrupted solar radiation from dawn to dusk.
And the soil itself fundamentally changes under those conditions, right?
Yeah.
Because instead of evaporating moisture, which would consume some of that solar energy, the soil just loses all its moisture and its thermal mass.
Exactly.
So all that solar energy goes directly into heating the air. It's a brutal cycle. And the numbers here reflect that. Dallas is 101, Austin is 102, the desert Southwest is under an extreme heat warning, Phoenix is at 112, Death Valley is approaching 121 degrees.
Just staggering numbers.
And then we have Las Vegas sitting at 113 degrees. But the
Okay.
report notes this is the 10th consecutive day Las Vegas has been at or above 110 degrees. So what does this all mean? My concern when reading this is psychological.
How so?
Well, 10 straight days of 113 degrees is mathematically extreme, but it reads like a standard Tuesday forecast in 2026. I wonder if the enterprise workers reading this have just completely normalized a climate state that is structurally breaking their environment.
It's a fair point. Baseline shifting is a well-documented psychological defense mechanism. Humans adapt quickly to new normals just to function daily.
Right, we get used to it.
We do. But physically, the infrastructure does not have that psychological luxury. When you have 10 days of 113 degrees in Las Vegas, the physical properties of asphalt, of concrete, and especially the power grid, they begin to alter.
The materials actually start failing.
Yes. The margin for error in the mechanical system sustaining human life in that environment basically drops to zero.
And the ripple effects of that heat are instantly visible on the map. The Mountain West is lighting up with red flag warnings. Wyoming is dealing with single-digit humidity and gusty winds.
A nightmare for fire weather.
Yeah. In California, the fuel dryness in the Sierra Nevada foothills is approaching record territory. The landscape is stripped of all moisture, just waiting for a single spark. And when those fires start, the report shows how fast the consequences travel.
Right across the map.
Yeah, Spokane and Boise are dealing with heavy smoke from fires in Oregon and the Columbia Basin. But what really caught my eye is the Midwest section.
The transport there is incredible.
It is. Fargo, North Dakota, and Sioux Falls, South Dakota, are experiencing smoke haze drifting in from those exact same western fires. Fargo is 1,200 miles away from the Cascades.
It's a long way.
How does a localized fire in Washington state degrade the air quality for someone stepping outside for their lunch break in North Dakota?
Well, if we connect this to the bigger picture, it perfectly illustrates atmospheric transport. A wildfire of that magnitude doesn't just burn along the surface, it creates massive thermal updrafts.
Like the heat is pushing everything up.
Exactly. The extreme heat of the fire propels the smoke and particulate matter tens of thousands of feet into the atmosphere, injecting it directly into the upper-level westerlies.
Okay. The prevailing winds.
Right, these are the fast-moving prevailing winds that flow west to east across the continent. So the heat dome over the central U.S. acts almost like a slide. The smoke rides the winds over the Rockies, and as it reaches the eastern edge of that high-pressure system over the Dakotas, the air subsides.
Well, things back down.
Yes, physically pulling that toxic haze back down to the surface right over Fargo and Sioux Falls.
It's a continent-wide domino effect.
Yeah.
The West catches fire, the smoke rides the upper atmosphere to choke the Midwest, while the East Coast stews in a 106-degree saturated boundary layer.
It really is all connected.
And all of this meteorological chaos is sitting at the very top of a publication aimed entirely at enterprise technology workers. Which brings us to the core tension of this entire snapshot. Because right below this map of a physically constrained, dangerous world is the Tech Archive for July and August 2026.
The contrast is quite something.
Here's where it gets really interesting. Because the tech sector is launching tools that demand unprecedented staggering amounts of electricity and infrastructure in the exact same week that the physical grid is maxing out, just trying to keep the population cool.
The contrast is, yeah, it's startling. You have server farms located in places like the desert Southwest powering these massive digital milestones. To keep a data center running when the outside air is 113 degrees requires immense cooling systems.
Right.
And those systems often rely on massive amounts of water evaporation. So in a region experiencing profound drought and record heat, you have an explosive new demand for water and power just to sustain the digital environment.
And the milestones they are powering are massive. On July 10th, 2026, OpenAI launches GPT 5.6 alongside ChatGPT Work, which is described as a unified AI workspace for enterprise knowledge workers.
Right, a major leap.
It is. I mean, it feels like reading a sci-fi novel. You've got society furiously building massive unified digital brains, while the physical environment outside their windows is quite literally on fire or underwater.
It's a surreal juxtaposition.
It is. And this isn't just a chatbot in a browser tab. The language here implies the AI is the actual operating system of your job. It's in your spreadsheets, it's summarizing your video calls in real time, executing workflows across different apps, and the report notes this relies on an incredibly high level of multimodality.
A key term, yeah.
I see that term everywhere in these updates, but mechanically, what does multimodality at the GPT 5.6 level actually entail for the hardware?
So multimodality means the neural network is no longer translating everything into text to understand it.
Okay.
It is natively processing diverse data types simultaneously. So GPT 5.6 isn't just reading a transcript of a meeting, right? It is listening to the audio tone, analyzing the video feed for facial expressions, and cross-referencing that with live enterprise data streams all at the exact same moment.
All at once. That's incredible.
It is, but the matrix multiplication required to compute those different sensory inputs simultaneously, it requires clusters of tens of thousands of specialized GPUs running at maximum capacity.
Which goes right back to the power grid struggling under the heat dome.
Yeah.
The computational cost is immense. And the friction isn't just environmental. It is structural and legal.
Yes, the lawsuits.
Exactly.
Yeah.
Just 5 days after that GPT 5.6 launch, on July 15th, the New York Times files for sanctions against OpenAI in their ongoing copyright lawsuit. They are specifically alleging that OpenAI withheld training data evidence. I want to look at the mechanics of this, remaining entirely impartial to the courtroom politics, obviously.
Of course.
What does it actually mean to withhold training data evidence when we are talking about a model as vast and complex as GPT 5.6?
Well, it highlights a fundamental incompatibility between legacy law and generative AI. In traditional copyright law, if you copy a book, There is a clear physical paper trail or a duplicated digital file.
Right, it's a copy.
But large language models don't store copies of articles. They ingest vast data sets during training and adjust billions of mathematical weights and parameters to learn the statistical relationships between words.
So it's not like a hard drive with a PDF on it.
No, not at all. So the New York Times is trying to prove that their specific copyrighted articles were ingested to adjust those parameters. To provide evidence of that training data, a company would essentially have to reverse engineer a massive black box neural network to show exactly which data points influenced which mathematical weights months or years ago.
It's like trying to apply physical speed limits to individual data packets on fiber optic cables. The 20th century legal framework is attempting to regulate a 21st century digital cognition process, and the court systems are just struggling to bridge the mechanical gap between the two.
They absolutely are.
And while the U.S. legal system is trying to untangle how these models are trained, the global development of this technology isn't pausing for court dates. We look at a headline from August 3rd, just days before our snapshot. It reports that a Chinese AI model, Moonshot Kimi K3, has matched frontier U.S. models and is now dominating the top 10 on OpenRouter.
Yeah, the presence of Kimi K3 at the top of OpenRouter is a critical data point for the geopolitical landscape of technology. OpenRouter is an API routing hub.
So how does that work?
It's essentially a marketplace where developers write an application, and OpenRouter automatically routes their prompts to whichever AI model provides the best result for the lowest cost and lowest latency.
So developers aren't loyal to a specific brand. They just want the best cognitive engine for their specific task at that exact millisecond.
Precisely. It is a pure, frictionless meritocracy for machine intelligence.
Wow.
If Kimi K3 is dominating that space over U.S. frontier models, it indicates that mathematically and structurally, the Chinese model is outperforming its Western counterparts in real-world, enterprise-level benchmarks. This raises an important question, right? It proves that the race to artificial general intelligence, or at least total enterprise dominance, is completely borderless and multipolar.
The U.S. does not have a monopoly on these breakthroughs.
Not at all.
So let's step back and look at the entire board of this August 7th snapshot. We have these massive leaps in digital cognition. GPT 5.6 and Moonshot Kimi K3 are fundamentally altering the speed and capacity of human knowledge work.
True.
We are building these infinite, borderless digital brains. But the physical servers hosting those brains and the physical bodies of the workers relying on them are locked in a world where Las Vegas is baking at 113 degrees for 10 straight days.
Yeah.
Where Flemington, New Jersey is paralyzed by stationary floodwaters. Where the air in Fargo is choked by fires burning thousands of miles away.
It is the defining paradox of this era. The digital reality is frictionless, accelerating at an exponential curve, and entirely unbound by geography. The physical reality is constrained, increasingly hostile to human comfort, and hyperlocalized.
Yeah, that's such a good point.
You cannot download an update to fix the saturated boundary layer, and you cannot run a massive multimodal AI inference without drawing power from a grid that is melting under a heat dome. The two worlds are on a collision course.
Which brings us right back to you, the listener. Why does this single day in 2026 matter to you? Well, it matters because you live at the exact intersection of these two realities.
You're right in the middle of it.
You are the enterprise worker logging into ChatGPT work. You are the one routing APIs through OpenRouter to optimize your daily workflow, pushing into this new frontier of digital productivity. But you are doing all of that while hoping your local power grid survives the afternoon heat, or hoping the smoke clears enough so you can just open a window.
Balancing two very different worlds.
Exactly. You're balancing the infinite expansion of the digital realm with the harsh, inescapable physics of the natural world.
And when you analyze the sheer processing power described in these tech headlines, the ability of a GPT 5.6 to simultaneously parse data, audio, and complex systems across an entire enterprise.
Yeah, that's why.
You realize that we have engineered the most capable cognitive tools in human history. The capacity to synthesize vast, interconnected variables is already here.
Which leaves me with this final thought for you to consider. If artificial intelligence is evolving as rapidly as this snapshot proves, if we are truly deploying these massive multimodal digital brains, well, perhaps the most urgent application for them isn't just summarizing meeting notes or automating enterprise workflows.
That's a fascinating thought.
Right. Maybe the most vital task for a Kimi K3 or a GPT 5.6 is figuring out how to untangle the massive interconnected climate mechanics that are locking down our physical world. Because you can build the smartest, most efficient digital workspace on the planet, but it doesn't matter much if the screen glowing red in your hand in the morning is telling you it's too dangerous to even step outside your front door.
It is a critical question of resource allocation and a truly fascinating look at the tensions of 2026. Thank you for diving into the archives with us.
It's been an incredible journey unpacking the snapshot. Thanks for listening, and we'll see you on the next deep dive.